And we are live, I guess. Hello, everyone. How it's doing? How's it going? Welcome to the introduction to the task 7, I guess. Um, let's take a moment to wait for people to join. And how is your task going? Oh, by the way, is everything okay with the sound, with video? Please type something in the chat if you hear me. Okay, welcome, welcome again. And hello, everyone. My name is Ivan, and I will be your host for today's session. While everyone is connecting, let's take a moment to review the agenda for today. So we will start with a discussion on monitoring and metrics, followed by a couple of words about Prometheus as our monitoring tool of choice, and then dive into the specifics of the task 7. Finally, we'll wrap up with the Q&A session if you will have any questions. If everything is going smoothly, please type something like plus in chat. I will understand that everything is working. Okay, nice. I see. At least one person is here, so we can continue. So let's get started then. So what is monitoring? The Google SRE book defines it as collecting, processing, aggregating, and displaying real-time quantitative data about a system, such as query counts and types, error counts and types, processing times, and server lifetimes. In other words, monitoring is all about keeping an eye on your systems to ensure they are running smoothly. It's not just about catching problems when they happen. It's also about understanding how your systems perform under different conditions. But why do we need this? Why do we need monitoring? Not only because all this visualization looks cool, but also we have a long list of actual business purposes. IBM proposes the following reasons for monitoring. Let's stop on each for a little. Performance optimization. Improving the performance of your systems can lead to better user experience, increased revenue, and reduced costs. Monitoring helps you identify bottlenecks and areas for improvement. By catching issues before they become critical, you can prevent downtime and reduce the impact on your users. Understanding how your systems perform under different loads can help you plan for the future growth and ensure that your infrastructure can handle increased demand. When something goes wrong, monitoring can help you quickly identify the source of the problem and take corrective action. SLA compliance. Service level agreements, or SLA, is a contract between a service provider and its customers that defines the level of service expected. For example, your website homepage should be available 99% of the time during a month. Monitoring helps you meet service level agreements by providing real-time data on system performance. By understanding how your systems are using resources, you can optimize resource usage and reduce costs. For example, if a server is underutilized, you might consider reducing its size or shutting it down entirely. Monitoring can help you detect security threats by identifying unusual patterns in system behavior. This can include things like unauthorized access attempts, suspicious network traffic, and other indicators of potential security breach. So, we decided to introduce monitoring into our project. What do we want to monitor, actually? There are a lot of metrics that you can collect from your systems. SRE book introduced so-called 4 golden signs: latency, traffic, errors, and saturation. Latency is how long it takes for the system to respond to requests. Traffic is how many requests are being processed by the system. Errors, how often the system is failing to process the requests. And saturation is how much resources the system is using. These metrics can give you a good overview of how your systems are performing and help you identify areas for improvement. Although I couldn't pass by the 4 golden signals, our model is focused on basic infrastructure metrics. Thus, our configuration can be considered as part for the saturation metric monitoring. Basic infrastructure metrics include CPU usage, memory, disk, network, etc. These metrics can help you understand how your systems are using resources and identify potential issues. For example, if a server is consistently run out of memory, you might need to add more RAM or optimize the way your application is using. We have already spotted the monitoring tool we will use, but let's take a moment to talk about it. We are going to use Prometheus as our monitoring tool. Prometheus is an open source monitoring and alerting toolkit that allows you to collect, store, and query metrics data. Its architecture can be seen on the slide. It consists of a server that periodically scrapes metrics from targets, like your servers or applications, stores them in a time series database, and provides an API for querying the data. Prometheus is a highly available tool because its deployment is self-sufficient and doesn't rely on external models. A couple of words about the parts of the Prometheus. The server is the main component responsible for scraping metrics and storing them in the database. Service discovery is a process of finding and monitoring targets. Prometheus supports various service discovery mechanisms. PromQL, or Prometheus query language, a powerful query language that allows you to perform complex queries and metrics on the metric data. Sorry. Push Gateway is a component that allows you to push metrics from short-lived jobs or batch process. And jobs or exporters are the targets from which Prometheus scrapes metrics. Also, Prometheus has its own alerting system that can send notifications with when certain conditions are met. This can be useful, but we won't use it because we will use Grafana for this in the upcoming tasks. Here, you can see an example of web UI of Prometheus. There are 3 different views here. All of them you'll be able to see when you deploy the Prometheus. However, please take a look at the documentation of it. There is a lot more to learn about it than we'll be able to cover here. And since we have already touched everything needed for the task, let's dive into it. The goal of the task is to deploy the Prometheus stack in the Kubernetes cluster and make it collect the basic metrics of the cluster, like CPU, memory, etc. You are not limited to these metrics, and you can configure Prometheus to collect the metrics of your application. But for the task, basic metrics will be enough. We provided 4 steps to achieve this. From our perspective, they are essential for this task, but they are not exhaustive. You might need to do additional research or configuration. Let me share my screen uh, so we'll be able to talk about the task a bit more. Okay, this is it. So the steps and objective is already covered. I want to stop a bit on the submission part. So the first thing you will need to provide is the pull request with automation of Prometheus deployment. It can be done in multiple ways. For example, using Terraform scripts or adding parts in your CI/CD pipeline. So this line is about the code. You will need to provide the code with which you actually deployed Prometheus. Second thing, an output of kubectl get pods. Since we deploy Prometheus in Kubernetes, to be sure that Prometheus is running, please just add the output of the getpods command into pull request description or README file. It will be enough to show that the stack is actually working. The third thing is including a screenshot of any metrics. For example, disk space usage. When you deploy Prometheus, the server of the Prometheus will have the part for web UI. It is not so powerful as Grafana, but it will be included. And basically, what this line is about is adding the screenshot of any metric that your Prometheus can collect from a Kubernetes cluster or nodes. So when you deploy the Prometheus stack, you will be able to get to this page. I deployed this in part as part of this task. So what I'm talking about is searching for any metric. For example, we talked about memory. So memory available bytes. Enter, and you will see graph. What you will need to do is just take a screenshot of this graph, and it will be enough for this. Please don't take screenshots now. It is considered as cheating. And the last part is providing the README file. Documenting the Prometheus deployment and configuration is a common thing for all the tasks. Just document all the things you have done, and you will be thankful to yourself in the future. This is it about the task. Evaluation criteria is about the submission parts, but with a distribution of points. Also, I added some references that can be useful for this task. It's mostly documentation, so feel free to use them for your task. And this is it, I think. I will be happy to answer all your questions if there are any. I don't see any questions yet regarding using. Thank you. Um, I hope it will be it. It was somewhat helpful. Um, okay, okay then. Um, in this case, um, thank you. Thank you for participating, for watching, and see you in the Discord channels. Have a great day. Bye.